Hello everyone, welcome back to Spectrum classes. In this video we are going to see the formal charge, how to calculate the formal charge in three simple steps, which is very easy to understand. And in addition to that, we are also going to see the resonance structure and the formal charge. What is the relationship between the resonance structure and the formal charge? How to decide this formal charge is very important to decide the resonance structure, which is more stable resonance structure out of number of resonating structures of a given molecule. So before going to discuss how to calculate the formal charge, we are just going to understand what is called formal charge. So formal charge of an atom in a molecule is the hypothetical charge the atom would have if we could redistribute the electrons in the bonds evenly between the atoms in the bond, right? So here is the formula to calculate the formal charges, right? So formal charge is equal to V minus S upon 2 minus U. Here V stands for valence electrons, S stands for shared electrons, U stands for unshared electrons. We are going to see few examples here in which we are going to calculate the formal charges. So here first we are going to see this BrCl3. So to calculate the formal charge, we have this formula as I told you. I am going to show you it in tabulated form, right? This BrCl3 is having Br and Cl, right? So first I am just going to calculate with this Br. How many valence electron this Br will have? Since this is the 17th group or 7th group element, so fluorine, chlorine and bromine. So it has 7 valence electrons. So I'm just going to show you here. It has 7 valence electron. This bromine, this chlorine also have 7 valence electron. So valence electron is done now. Now what about this S? So this Br is having 3 bonds, right? 1, 2, 3. So 3 bonds have 6 electrons. And this 6 electrons, since 1 electron is shared by each participating element, therefore we are going to divide it by 2. Or simply you can calculate the number of bonds and you can write down in this manner 3 only, right? So here this is the valence electron and these are the shared number of bonds, right? So one bond, second bond and third bond here. Now number of unshared electrons. So unshared electrons are 1, this 1, 2, 3 and 4. So 4 unshared electrons are there. Now we are going to put all the values here, 7 minus 3 minus 4. So this will gives us 0. So here is the formal charge which is 0. So only these 3 values you need to know to calculate the formal charge. That is why I have drawn this molecule, right? Otherwise you can see simply by looking this, we are 7 valence electrons, 3 bonds, minus 3 and how many lone pairs? Since 3 bonds are formed, so 4 electrons are left. So simply you can write down 4. So this 0. Fine. So either way you will find, once you will understand the concept, you will be able to calculate it directly, right? So here Cl having 7 valence electron and each Cl is having 1 bond. So I have written 1 bond, 1 you can write down in this manner, or 2 electrons are there shared by 2 atoms. So 2 divided by 2. So in this manner we are going to have 1. Now number of lone pairs. So number of lone pairs, since out of this 7, 1 electron is shared to bond formation and 6 electrons are left. So simply 7 minus 1 minus 6, so we are having 0. So the molecular structure is preferable, which is having 0 formal charges, right? So here in this formula we are having 0 charge on both the atoms. So this is having 0 and these chlorines are also having 0. So such kind of molecule is preferred. The next example is this. And here is the formula to calculate this. Now we are going to calculate, since we are having 2 different kind of atoms, so nitrogen and hydrogen. right? Nitrogen is having 5 valence electrons and it forms 4 bonds, right? In this manner. How many electrons are left unshared? So nothing is left unshared. So 5 minus 4 we are having plus 1. Now for H we are having this 1 valence electron and it forms 1 bond only, right? So 1. So 1 minus 1 we are having 0. So nitrogen is having plus charge in this molecule. This plus charge is with this nitrogen. Now the next example. So we are just going to draw the next structure. So here is the square planar structure for this ICl4 minus. Here we are having two different atoms. So first is iodine and the second one is chlorine in this molecule. Now both are having 7 valence electrons. Now this iodine form four bonds, 1, 2, 3 and 4. So 4 bonds it forms, and how many electrons are left over there? So it has 4 electrons over there, right? In this manner we are going to calculate. So 7 minus 4 we are getting 1. Now the question comes, if we do not know what will be the structure, then how we are going to calculate? I am coming to that point only, but before that I am just going to calculate the Cl first, right? So Cl has 7 valence electron and it forms one bond, right? So one bond is there. How many electrons are left unshared? So 6 electrons are left unshared. So here it is having 0 formal charge over there. So it means this is having minus 1 and all chlorines have 0 formal charge. If suppose I do not know this structure, then I Cl4 minus. So here this I is having 7 valence electron that we know. How many bonds are formed in this? So it formed 4 bonds. So minus 4. How many electrons are left? So ideally 7 minus 4 we are having 3. But if I put 3 electrons over there, 1, 2, 3 and 4 are there. So 1 electron left unpaired. So this minus will come over there. Simply you can understand in this manner also. Fine. More than 7 cannot be there until unless no charge is there. Fine. So this is how we are going to understand. So with this I minus we are having, without knowing the structure, which kind of structure it will have, we can calculate the formal charge. Second is, what about this chlorine atom? So this chlorine atom is having 7 valence electron minus how many bond it form with this iodine? It form 1 bond, as we can see, minus number of unshared electrons. So since 1 is shared in the bond formation, left 6 are there, no other charge is there. Fine. So in this manner we are simply calculate this formal charge. Now we are having this ozone. So ozone is having this kind of structure. We need to calculate the formal charge on these 3 oxygen atoms, right? So here I am just going to show you for the first molecule, this one. For this one we are just going to calculate. So for oxygen number 1, here I have written. So this oxygen is having 6 valence electrons. So you can see for 1, 2, 3 I have written 6 valence electrons. Second is, this oxygen form 2 bonds. So 1 and 2. So 2 bonds are there. Now how many unshared electrons are there? So 4 electrons are left. So this oxygen is having 0 formal charge. Now the second oxygen. So what about the second oxygen? So 6 minus how many bonds it form? 3 bonds it form. And how many unshared electrons are there? So 2 electrons are there. So 1 formal charge is there on the second oxygen. What about 3? Oxygen number 3. So oxygen number 3 is having 6 valence electron, 1 bond minus 6 unshared electron. So this has minus 1 formal charge. And overall we need to calculate on the overall molecule what is the charge on this molecule. So overall charge is this plus 1, this minus 1, this gives us 0. Fine. So total charge on this molecule is 0. What does this formal charge tells us about this molecule. So this molecule can be written in this manner. So here this oxygen is having +1 charge and this oxygen is having -1 charge. And here I am just going to show that the Lewis structure, which is having the adjacent opposite formal charges, are stable as compared to the molecules which are having same kind of charges, right? So plus charges on adjacent atoms will not be accepted for the resonance structure. So this kind of molecule can be accepted, right? The next example is how to decide the resonance structure. So this isocyanate, out of these three, which one is more stable, right? Because this is the significance of calculating the formal charge. It helps us to select the most stable structure, that is one with the least energy out of different possible Lewis structures. Out of these three, which resonating structure is the most stable resonating structure on calculation of this formal charge? So here is the formula, and for these three molecules we are going to calculate the formal charge on each atom, and from where we are going to decide the stability or more stable or more appropriate resonating structure for the molecule, right? So here I have written nitrogen, carbon and sulfur, and here is the total charge. So we are going to decide for first molecule. Here is the first molecule for which we are going to decide the formal charge on each atom. So first for nitrogen. So here nitrogen is having 5 valence electron, and how many bonds are there? So 2 bonds are there, 2. And how many unshared electrons are there? 4 unshared electrons are there. So in this manner, this nitrogen is having -1 formal charge. Second is carbon. Carbon is having 4 valence electron and 4 bonds it form here in this molecule. No unshared electron is seen over there. Actually these molecules are given in the question. So this carbon is having 0 formal charge. Now coming to the sulfur atom of the first molecule. So here is the sulfur atom, and since this is of oxygen group, so this has 6 electrons, valence electrons, and 2 bond it form, and 4 unshared electrons are there, 2 bonds here you can see, and 4 unshared electrons are there. So in this manner it has 0. In total this molecule has -1 total charge. Coming to the second molecule. So in this second molecule we are just going to calculate this nitrogen. So nitrogen, we are not going that how many electrons it has right now, right? So here 5 valence electrons are there and it forms 4 bonds. No unshared electron is seen over there. So here we are having +1 formal charge. Second is carbon. So carbon is seen that for this carbon we are having 4 valence electrons, 2 bonds we are going to see this 2 bonds, and 4 unshared electrons are there, so it has -2. Fine. Now coming to the next, sulfur. Sulfur is again having the same structure as in the case 1. And if we are going to add all these formal charges, this +1 -2, it gives total charge -1. Now coming to the molecule number 3. So in this case we are going to calculate first for nitrogen. So nitrogen is having 5 valence electrons. 2 bond it forms, here you can see, and 4 electrons are there which are unshared, here you can see, right? So in total in this manner we are having -1. For carbon we are having the same structure as in case of second, so -2. And for sulfur we are having here 6 valence electrons and 4 bond pairs, right? Here 1, 2, 3, 4. So 4 bond pairs are there and no unshared electrons are there. So in this manner we are going to calculate this +2. If we add all three, this -1, -2, +2. So we are overall having -1 total charge. This -1 total charge is shown over here. Fine. And from here we are just going, out of these three, total charge is same in all 3 molecules. But which structure is preferable? So out of these 3, only this molecule is having least formal charge on its atoms, right? So this has -1. However, here in this case we are having +1 and -2. So this is less preferable. Here third molecule is having -1, -2, +2. So this is least preferable, right? So in this manner we are having the first molecule which is more preferable structure for this isocyanate. So this one is the most preferable structure. Here I have just written the structure with the lowest number of non-zero formal charges is preferable. The next is, if we are having this kind of structure, so we are here we have calculated the formal charges +1, -1. So which one is preferable out of these two? So the first one is preferable out of these two. Why? Because in this case more electronegative element is having the negative sign, whereas in this case this more negative element as compared to the hydrogen atom, this is having the positive charge. Therefore this molecule is discarded. I hope you find this video helpful. Thank you all. Thanks for watching.